In this video, we'll write the Lewis structure for RaCl2. That's radium chloride. So first we have radium, that's a metal, chlorine's a nonmetal. We'll treat this as an ionic compound. So when we write the Lewis structure for RaCl2, we're going to put radium, that's the Ra, and then we'll put a Cl on either side of it. Radium's in group 2 on the periodic table, so it's going to have 2 valence electrons. Let's put one on either side of the radium. And then chlorine, group 17, sometimes called 7a, that has 7 valence electrons. So we'll put 7 valence electrons around each chlorine. So because RaCl2, it's an ionic compound, the metal will transfer its valence electrons to the nonmetals. So the radium, it'll lose this electron to the more electronegative chlorine atom right there. That gives the chlorine an octet, very stable, and then this one can go over to this chlorine. That gives this chlorine here an octet as well. So you see why we need 2 chlorine atoms for the 1 radium atom. And the radium has a full shell underneath, although we don't draw that. The chlorine here has gained electron. Since electrons are negative, it'll have a 1- charge. Same here, 1-. The radium, it lost 2 electrons. So because of that, it'll have a 2+ ionic charge. The positive radium here will attract the negative chlorines, form an ionic bond. Let's put brackets around each chlorine, and that'll show that the electrons were transferred. They're not shared like in a covalent bond. The metal transferred its valence electrons to the nonmetal to form the ionic bond. These negative chloride ions, they're attracted to the positive radium, and this is the Lewis structure for radium chloride, RaCl2. Do note, if we had a crystal of radium chloride, it would be made up of a repeating pattern of this Lewis structure here. Call this a formula unit. But this is useful, shows us how the radium transferred its valence electrons to the nonmetal, the chlorine, to give us the RaCl2 Lewis structure. This is Dr. B, and thanks for watching.